Colors. It's always a good idea to squeeze every little bit of performance and reliability out of your home storage. In this video, we're going to discuss how to do just that with RAID. Let's do this. One of the reasons I switched to running everything in VMs is to make it substantially less complicated to back up my OS installations. By the way, if you're wondering why I did this in the first place, you can watch the previous video. The probability of losing data between backups is still there. If I have a 500 gigabyte OS installation, it's not a very good idea to perform an hourly backup for it, for example, because it will heavily affect your system performance and it requires you to shut down whatever it is OS that you're backing up. For file backups, Windows 10 has a very nice backup feature, but unfortunately it doesn't work with network storage. And the legacy Windows 7 backup feature that still exists in Windows 10 is considered deprecated. For Apple's Time Machine, it's not a problem in any way. It keeps an hourly backup for the past 24 hours and a daily one for the past week and a weekly one for the past few months until you basically run out of storage. And it also supports backing up through network drives. OS X has really set the bar very high when it comes to backups, so good job, Apple. So what if you want to crank up your data reliability and performance game? This is where RAID comes in. So what is RAID? RAID is short for Redundant Array of Independent Disks. It's basically a storage virtualization technology used to add redundancy, performance, or both by combining multiple physical media into virtual ones. Imagine you have two identical storage media, like two SSDs or two hard drives. When you add storage virtualization, you can, for example, strip data equally to both drives, doubling the overall size and performance. The performance gain happens when you write a file, for example, the file is split into small chunks and divided so that each half is written on each disk. So it will take half the time, basically, for each disk. Therefore, double the performance. Same with reading files. Each drive has half the file, so it will take half the time to read it. And all of this is encapsulated by RAID. This particular configuration is called RAID 0, or data stripping. It doubles the performance by stripping data across multiple drives, and the effective storage is basically the sum of all storage media in this RAID configuration. The downside of this configuration, if you lose one drive, you lose everything. Another known configuration is RAID 1, which mirrors data across drives. So if you store a file will be stored on both drives. This doesn't have a performance gain at all, but it provides data redundancy. Should you lose one of the drives, you have an exact copy of it, or a mirror. So this provides data redundancy, doesn't provide any performance gain, and also the effective storage in the case of having two drives, it's basically half the sum of those two drives. There is another interesting RAID configuration and this is the one I'm using in my home NAS, which is RAID 5. I'll give an example with the minimum number of drives required by RAID 5, which is 3. Data is stripped across two drives, and the third one has what's called parity. So for each two stripped blocks on the first two drives, there is a parity block on the third one, which is calculating using the first two blocks. So when you have two data blocks and their parity, if you lose one of them, you can calculate what you lost with what you have. Also, the nice thing about RAID 5 is it doesn't have a significant hit when it comes to the overall effective storage. I should mention something. In a RAID configuration that tolerates drive failures, when a drive fails, even after you replace it, your RAID setup is not out of the waters yet, because it goes through what's called a rebuilding phase, where it tries to populate the new drive with what was originally on the old one, and it takes a long time to do so. For example, in my home NAS, which is not a very high-end machine in any way, it took an entire day to rebuild my RAID configuration, and that's just because I added one more drive. And I'm not even talking about the check that happens initially when you create a RAID configuration, just to make sure that the drives are healthy. No, I'm talking about actual time that the NAS took to rebuild the RAID configuration. There are many other RAID levels out there, like for example all the numbers between 1 and 5. And there is even a RAID 10, short for 1 plus 0. Each one has their performance impact and drive failure tolerance. There is a link to an article explaining different RAID configurations in the description below. So let's talk about RAID management. RAID can be managed by software or hardware. Software RAID can be configured on almost any operating system, and all RAID-related operations happen on the operating system level, which means it will utilize some of your CPU processing power. As an example, the parity computations in RAID 5 will happen on the CPU. Also, when you're running multiple operating systems, you might need to configure your array on all of them. For example, mine is automatically detected on Windows 10, but it doesn't on Linux, and I have to do it myself. Hardware RAID, however, is completely encapsulated from your operating system. You'll need to install a RAID controller and connect your storage array to it. All RAID-related operations and processing will happen on this card, totally away from your operating system and CPU, including parity calculations, to the level where your OS won't be able to see individual disks or SSDs. What your operating system will see is logical storage that you configured on the RAID controller. Okay, how about me? Well, I have two storage units at home. One is a home NAS, and the second is my PC. I chose RAID 5 for my home NAS with 3 4TB drives, giving me the total capacity of 8TB. On the PC side, I have two WD Blacks on RAID 0, and I mainly store downloaded games on those drives, because in case those drives fail, I can always re-download those games. However, for the boot drive, I'm using Corsair MP610. It's a 960GB SSD, and unfortunately, I don't have any redundancy for this SSD whatsoever. And the main reason why it's not redundant is because it's an M.2 SSD and I only have one M.2 connector on my motherboard. And even if I had multiple M.2 connectors on my motherboard, I don't have enough PCI Express lanes to connect two SSDs. And the reason why I don't have enough PCI Express lanes is because I have two GPUs installed on my computer for my virtual machine setup. If you're wondering, what is a PCI Express lane? Well, I'm gonna make a video about that soon, so stay tuned. Okay, so I think my storage setup is good now, and I can stop worrying about losing the first few lines of code I wrote when I was 14 years old. Thank you very much for watching this video. If you liked the video, please hit the like button. If you want to see more videos like this, please subscribe. And if you have any comments or suggestions, don't forget to leave a comment in the comment section below. And I'll see you in the next video. Peace.